Good morning, or I guess afternoon, depending on when you're tuning in to watch this video. Not necessarily when I'm making it, but our next video is on writing linear inequalities from a graph. We're going to start with just a single inequality, then we will get into a system of inequalities. So if you're tuning in to watch this video to learn about how to write a system of linear inequalities, you might want to jump ahead a couple of minutes because we've got to talk about this one first. If you look at this, a couple of things you should notice right away is this green line seems to have open circles, which if you know me, I like to use those open circles because points on this line are not technically solutions to this system, this linear inequality. And I can show you more about that in another video, but that's why we need some open circles here. It's also a dashed line, and so even if you don't have open circles, those dashed lines should definitely key you in on the fact that this is either a less than or a greater than picture. Certainly no less than or equal to or greater than or equal to, because there's nothing on this line that is equal to a solution. It's either less than or greater than the line. And so that's actually how you start to build this up. If you are trying to write the linear inequality from the graph, it's kind of like playing a game. You need to fill in a lot of pieces. Here's our slope-intercept form, y equals mx plus b. But we're going to change some things, okay? First of all, we know this equal sign is no longer going to be an equal sign because I have a shaded region. I've got to fill in the slope, so that will no longer be an m, and I've got to find out what is the y-intercept, so that will no longer be a b. So it's almost like I said, playing a game where I've got to fill in this box, the x can stay, and I have to fill in the y-intercept. There are three things I need to find: the sine, the slope, the y-intercept. I tend to think the y-intercept is the easiest one. Y-intercept, always easy to spot because it's where the line crosses the y-axis, and so that's 1, 2, 3, 4 values in the positive direction, so I could fill that last box in with a +4. Then most people think, just because of terms of work, finding the sine is the next easiest, especially if the slope is not easy to tell. So this sign, like I pointed out, open circles, dashed line, that means it's either less than or greater than. I'm clearly shading below this line, that means I'm going to be less than. And then I need to find the slope. Well, you can find the slope between any 2 points on a graph, you just need to count. So rise over run, I'm definitely rising but in a negative direction, so that would be a -2. And as I run to the right, 1, 2, 3, 4, 5, I rise, -2, run 5, so that would be a slope of -2 over 5. Let's rewrite this as our final answer, y less than -2 over 5x plus 4. That would be the linear inequality associated with this graph. Okay, let's move on to a little bit more difficult of a question. This is now a system. You know it's a system because all that it takes to be a system of inequalities or even a system of equations is more than one line. Could be 3, could be 4, but a lot of times you're going to see it with 2. I have lines in green and red, and I have a green 1 and a red 2 because we're going to write our 2 lines off to the side. And so you can make that template that I did last time. I'm actually going to do mine in pencil a little bit lighter so I can write my final answer. In fact, you can't even see that, so I'll just end up rewriting my answer. So we have a y, and then I need to fill in this box. I can always put my x, and then a third box for my y-intercept. Same thing for line 2. There are 3 things I want to find. So again, just like a game here, I'm trying to fill in certain things so that I can determine what my 2 lines are. Just like last video, I think the easiest thing was to determine was the line and the dots. In this question, solid lines, solid dots. So I know these 2 signs are definitely going to be equal to signs. I'm including values on these lines. So maybe you want to start there. Some people think the y-intercept is easier, but while we're talking about it, let's start with the signs. The green line, I am shading above that line. When you are shading above that line, that means I am greater than or equal to, because it's a solid line. The red line, I'm also shading above that line. So that would still as well be a greater than or equal to sign. Moving on to the y-intercept, that's the next easiest thing. The green line, the y-intercept a little bit bigger than the red line, so let's actually just do the red first. The red line would be +1. Green line also a positive y-intercept, but a little bit higher. So 1, 2, 3, 4, 5, 6, 7. So +7 for my green y-intercept. And now finding the slope. What's nice is I definitely have 2 points on the green line and 2 points on the red line. So finding the slope won't be too bad. Again, I'm going to start with the red line just because those points are right next to each other. I'm going to go down 1 to the right 1. Well, that's a slope of a -1. Down 1, right 1, down 1, right 1. The green line, I actually go up 1, 2, 3, 4, 5, 6 values. And to the right, so this is a positive line, 1, 2, 3, 4. But we should always reduce our slopes. 6/4 is the same thing as 3/2. So again, this is kind of messy with all these boxes. I'm going to rewrite my final answer. And a lot of times you'll see systems with these curly braces. My system final answer would be y is greater than or equal to 3/2x plus 7, and y is greater than or equal to a -x plus 1. That would be my final answer to writing the system of linear inequalities. Let's do one more. You could, after looking at this, pause the video, and if you would want to do this on your own, you're more than welcome to. If you still feel like you need to follow along, go ahead and follow along. And I'm going to leave my picture just like this, because you can see up here is where I'm going to write my 2 inequalities, and you can certainly tell where I'm shading down here. Here's the original picture. If you want to take a pause right there, that's the origin right in the middle there. But I'm going to just move this a little bit so that I can see that 1 and 2 a little bit better. Alright, so this time, and if you knew this was going to happen, I've got 1 solid line and 1 dotted line. Open dot, solid dots. And it looks like they actually do cross. Now remember, system of inequalities don't need to meet at a specific point. System of equations would meet at a certain point, and that would be actually my solution. But we're looking at linear inequalities. So the fact that they meet is not necessarily a good thing, but it's not necessarily a bad thing. It just means they share a point. Now, while we're talking about that, I just want to key you in on something. That point would not be a solution, because remember why I like these open dots. This is a dashed line, open dots. This point, although it would work as a solution to the green line inequality, it would not work as a solution to the red line inequality, because points on that line do not count. So just something to know, but not really why we're here. We're here to write these 2 lines in slope-intercept form. So I'm going to skip the boxes that I've been doing. We're just going to get right to it. I know I need a y. What would my sign be for the green line? Well, again, it looks like I'm shading below or beneath that line. So that's going to be less than, and because it's a solid line, less than or equal to. Now, I'm going to go again and jump right to the y-intercept. It's the easiest thing. Even if this y-intercept is so high up, all I'm doing is counting. Easiest thing to find. 1, 2, 3, 4, 5, 6, 7, 8, 9. That y-intercept is a positive 10. I know I'm going to have an x. I've just got to find my slope. So, use the 2 points to my advantage, and let's count. Slope definitely going to be negative as I'm going downhill as I go left to right. So, down 1, 2, 3, 4, 5, 6, 7, 8. So I go down 8 to the right 1, 2, 3, 4. Negative 8 over 4, everyone knows, reduces to a negative 2 over 1. So I can just call that slope a negative 2. So there's your green line. Y is less than or equal to a negative 2x plus 10. Moving to the red line, again, I know I need to start with a y. I'm also below that line, so less than, and because it's dotted, we're going to stay strictly less than. It goes through the origin, which means you could put a plus 0 here, but my y-intercept's non-existent. I'm actually not going to write anything. I'm just going to fill in my x and be ready to write my slope. This time, again, remember they share that point. I go up 2 to the right 4. So up 2 to the right 4, it's kind of like the opposite of this. It's only 1/2, not 2 over 1, 1 over 2. And certainly positive because as I move left to right, I'm going uphill. So that's a positive 1/2 slope. There's your system of inequalities that represent this graph with the shaded region below both of those lines. Thank you for tuning in.